So, what is an intelligent enterprise? How do you build an intelligent enterprise using these emerging technologies as AI, machine learning, mobility, and cloud services? Well, this is the topic of this panel today, and moderating this panel is Mr. Ryan Mallory from Equinix. Mr. Mallory is the Vice President of Global Solutions Architects. He has an expertise in the IoT space, mobile integration points, as well as distribution infrastructures of these different IoT devices. He has been guiding future IoT, Fortune 500 companies in this IoT space, creating their roadmap as well as creating an execution plan for these roadmaps. He's also an advisor of several startups in the Silicon Valley. Those startups are engaged in building these smart cities, interconnecting IoT devices, humans, and all other relevant components. So with that, please welcome Mr. Ryan Mallory.
Afternoon, everybody. It's a pleasure to be here for another CIO Symposium here at MIT. Real fortunate to be with this distinguished group of individuals here. I'll let them do a real quick intro so everybody understands what their backgrounds are and who they are, and then we'll jump into some of the discussion points that, pardon me, that I think you guys will feel real interesting. So just quick rundown on who you are, where you're at, and what you do.
Yep, so my name is Stephen Taylor. I'm the Senior IT Manager at Devon Energy. We're a Fortune 500 company focusing on oil and gas. I'm leading all of our research and development areas around AI, machine learning, and the migration to the cloud technology. So that's a little bit about who I am and what I'm working on.
Awesome, thanks, Stephen. My name is Alston. I'm the CEO and co-founder of Entefy. We're an AI intelligence and communications company based out of Silicon Valley. We are not a Fortune 500 company. We're a very small chili pepper team working on some of the coolest stuff right now that's directly related to the topic we're talking about today.
Hello, my name's Hugh Owen. I work at a company called MicroStrategy. We've been around for 30 years. We were actually founded in a dorm room at MIT by a gentleman called Michael Saylor. We provide analytics and mobility solutions to enterprises globally, headquartered just outside of Washington, D.C. And personally, I run our product marketing function and our product function.
I'm Michael Woods. I work for CDM Smith, headquartered here in Boston, Massachusetts. I'm the VP of Information Technology. My primary goal is sustainable innovation and how we can improve our client services in engineering, wastewater, transportation, design and construction, and I'm focused right now on AI, machine learning, and robotics process automation.
Great. Thanks, guys. Well, let's go ahead and jump right into it. So, the industry and a lot of the topics that are being discussed here today are around AI, machine learning, and the adoption of cloud at the edge. So, want to just get some quick feedback from you on, where you're at and kind of that development process and those deployment models. So, Stephen, if you want to just jump right in, and you guys feel free to, talk through this as we go along.
Okay. So at Devon Energy, we really exist in the upstream space. So for those that aren't familiar with oil and gas in the upstream space, the upstream is who goes and finds the oil, takes it out of the ground, and sells it to the market. There are other companies that deal with midstream refining and pipeline and distribution to customers, but we're really in that pure upstream space. And the three areas that are critical to us are getting the oil out of the ground faster and better and more accurately, drilling it and producing it, and delivering it to the pipeline services or operating those. And in those areas, we're really focused on applying AI and machine learning on the seismic and all of the scientific data. It's very, very large data sets, petabyte class data sets that are very noisy, and using AI to do what traditionally has been done with either high performance computing clusters, moving that to algorithms and automated machine learning away from just standard people hunting through numbers. On the drilling and production side, we're really looking at how do we make the autonomous drilling rig a reality, right? So like autonomous driving of cars, how do we drive that? It's a dangerous industry. We don't like people getting hurt. And so how do we move people out of that equation for safety reasons? And then the last one is around production operations is really predictive asset management and applying that at scale and getting to where we can do management by operation. So those are kind of our 3 focus areas.
Got it. Good. Hugh, any insight on how you're looking at AI and machine learning?
Yeah, so I mean, my perspective, obviously, or MicroStrategy's perspective, covers 2 vectors, right? We have a solution that we sell in the market, so there's that perspective in terms of how organizations are using that, and then we also drink our own champagne, so there's that perspective too, or eat your own dog food, as is probably more familiar known. In terms of what organizations are using MicroStrategy technology for and how we're investing in that technology, there's sort of two ways we think about AI and machine learning. One is injecting the benefits of AI and machine learning directly into the workflows of the product. Like, if you look at analytics, right, the sorts of analytics that someone could generate by dragging and dropping things onto visualization can be much more easily accessed if someone can type in a Google-like question, and then the analytics automatically get built. That is an AI-driven workflow. It doesn't immediately say on the screen, you're using AI now, but it's AI. Same as the voice applications. There's AI injected in multiple different parts of the solution that organizations are using. It's almost hidden to a certain extent. And then there's the more obvious in-your-face use of AI, where you have a data scientist who is building an algorithm using R or Python or whatever it may be, training that model on top of the data before then embedding it in an application. So we see, obviously, the adoption of AI when it's in the workflows, when it's injected in workflows in products, is quite pervasive. AI, as it's applied by a data scientist to the data, is much further left on the adoption scale and requires a higher set of skills. But there are some really great use cases of people who are now making significant inroads into tapping into the benefits that are available to them on that vector.
Got it, got it. Hey, Mike, I know that CDM Smith is very involved in a lot of the smart city technologies that are out there, and and as a construction company and managing a lot of those capabilities out there, can you share with the audience just a little bit of some of the trends you're seeing and how they've impacted CDM Smith?
Sure. So in the smart cities arena, what we're looking at right now is really around intelligent transportation and infrastructure. So we're focused in on what the cities are going to need and when they're going to need it, and using AI and machine learning, able to adopt some of those things. One of the things we're looking at right now is using intelligent camera systems and being able to do vehicle recognition, so we know when we have more electric vehicles on the road, where those vehicles are going, prepare and plan infrastructure and installation services for those ahead of time, and also make sure that we're able to capture what people need in each section of the city, like I said, more in advance of when it's actually being consumed.
Got it, got it. Hey, Alston, as you're starting to look at some of the capabilities that Entefy is bringing to the market that I think are very unique in image recognition as well as deep learning, how are you and Entefy starting to look at the marketplace for enterprise-based adoption to be able to lean in and help some of these examples that Stephen and Mike have talked about?
Absolutely. So we tend to see 2 big vectors for not just our solutions, but AI augmentation in the workplace in general. We see areas where enterprises can radically transform, in fact, their internal operations, and also where they can improve products and services and have the intelligence be, almost as Hugh mentioned, almost invisible in some respects and manifest itself in unique types of customer experiences or unique capabilities to drive productivity. From that perspective, from the CDM conversation as well, one of the things that stands out is vision. Vision is one of those areas where I think AI has proven extremely useful. There's already some very serious use cases out there where vision can dramatically transform the capabilities of a given company or improve security in many different ways. What we're noticing, though, is that if you take that sort of paradigm around massively high-density compute, which is required to inherently do vision at scale, and you start to apply that same type of infrastructure and those same type of considerations to other areas as well, you can end up empowering knowledge management systems to do things that nobody's ever thought possible. You can empower intelligent workflow orchestration, which that's one of the things you mentioned. We call it intelligent workflow orchestration. It's this idea of how do you have an AI system that can look at all the endpoints in a given network or look at all the different capabilities that exist at sort of a functional code level, and how do you have it self-optimize and self-orchestrate to accomplish tasks for a given person. And then ultimately, everything we're talking about here has to end in somebody in the enterprise using something. And that's where things like natural language and other similar spectrum of technologies become very useful. So vision is a huge area of our capabilities. We made the sort of, I would say we made the charter very early on to say we were not going to go into image recognition or just object recognition in still frames. We were going to take everything we did in a single frame, we were going to apply it to video, which is a very unique offering that Entefy puts together. Most video recognition capabilities are much more finite than those that you would traditionally find for images and other things, but that unlocks massive opportunities wherever you have, security becomes an issue, wherever you have lots of cameras and those kind of things, so for smart cities and other areas.
Good, good. Hey, and everybody, just a quick reminder that we're using Slido for questions. If you have anything that's striking a question that we're talking about, please just submit it, and they're coming in up here, and I'll occasionally reach down and ask some of the questions to the panel, and so we want to make sure that we're having this fairly interactive as well. So we'll kind of jumping into this concept of trying to bridge the enterprise with AI facilities. We've heard Hugh and Alston talk about the capabilities and needs. How are the enterprise guys up here looking at AI as a mechanism to be able to diversify or make better decisions around multi-cloud data flows? Any insights on that, Stephen?
Yeah, I think one of the biggest ones for us is we started out early on doing a lot of our AI type efforts on premise. And one of the things we found really quickly was that the cloud vendors and the people who are providing software through SaaS services and other development kits were drastically outpacing our ability to keep up. And so by starting to leverage the cloud services to do those workflows and the work, we're suddenly kind of starting to leapfrog a lot of the different type of business problem challenges that we were facing. The balancing act for that is, in order to do that, you also need all your data there, right? So, and for us, especially like in the first example I gave on looking at our seismic data to look at where we should drill next, there are petabyte class volumes. So how do you move these really large data sets around to multiple providers? So we've been starting to really think through how do we partner with some people with reusable technology that we can get them in and co-locate the AI logic with our data. So that's been a pretty unique challenge for us.
Yeah, I mean, with the way we've approached the challenge or the opportunity of cloud, initially we dedicated an entire team to setting up a cloud infrastructure that we hosted somewhere in Northern Virginia, and then we quickly realized that that was a huge amount of overhead. So we moved then to hosting the cloud platform as a service version of MicroStrategy in AWS, which the benefits there, that versus the on-premise version of our software, which has been around for many, many years, was the ability to automatically vertically scale, horizontally scale, to do that based on a certain time window on a Monday morning when the system's going to be overloaded, or to now predict based on previous activity when the system should just go ahead and automate that scale, has been a huge benefit to organizations that are using software like MicroStrategy in AWS or in Azure. So that's been a significant help. In terms of, you mentioned what are the benefits enterprises have gotten from both the cloud but also from these AI ML applications. I mean, a really good example locally is Boston Children's Hospital. So Boston Children's Hospital, I know it just because they use our stuff, have a major issue in terms of capacity, in terms of beds. And so they've consolidated all their information to a single place, and they've used predictive algorithms, machine learning algorithms, so that when someone comes into the emergency room, they will know within 30 minutes whether or not that person is going to need a bed before that person has even been assigned a bed. Right? So now they can better manage the resources within the hospital, the beds. They've also got machine learning algorithms that they apply at the end of the stay as well. They can predict better than the rule of thumb or the gut instinct of the doctors and the nurses when that person will no longer need a bed. And so they're applying, because they've got the information at their disposal, they can now apply these machine learning models effectively using a cloud deployment, using an application like MicroStrategy to drive those metrics into the workflows that the nurses and doctors are using.
I do want to touch base, if you don't mind, on that real quick, just to say that I think what we're seeing, and we do see quite a bit of use cases like the ones you mentioned, but for us, our focus was always on multimodality, right? So there are a lot of companies and a lot of services and a lot of great technologies that create solutions or enable solutions that can do one thing very, very well, or even a small cohort of things that are very related. Classic examples of this would be, all the big names that we know about, all of them having, image recognition APIs, or all of them having, conversational APIs, or text-to-speech, or speech generation, or things like that. What we end up seeing is that if your use cases require multimodality of information, what could that be? It could be, well, a single video stream actually is a multimodal inherently, but you could also have things like in knowledge management, you have, terabytes upon terabytes or hundreds of terabytes, in some cases even petabyte scale of just, information, text information, images, videos, things that an organization has built up over time as an overall knowledge base. That's the kind of set of use cases. If you want to take that data and make it smart, take those, as we call dumb pixels, and make them smart pixels. If you want to do that, that's not a linear process. It's not the kind of thing that you can generally really go to a cloud provider and say, oh, I know my exact scale that's going to be working here. I know my exact workloads. Like, can you give me a per instance pricing that really is going to fit my end goal? So we end up finding that, especially in the discovery phases with most enterprises, the hybrid approach tends to work the best, because you end up having, in many cases, lots of information that may or may not be readily accessible to the cloud, or if it is, that traffic up and down is counted differently and things like that. There's a lot more considerations there than most people think about. But then on top of that, there's also high performance algorithmic tuning that happens as well, right? So if you can have algorithms that scale really well on CPU computational workloads, that's a different cost vector than if you have something that requires a lot of deep learning and a lot of GPU-centric, we'll just create that whole class as sort of GPU-centric workloads, where even cloud providers today tend to struggle a little bit with keeping at the cost per performance to a well-optimized internal infrastructure. So I do think size and scale matters there. The benefits of the cloud at big scale, we need to spin instances up to run an application, don't necessarily translate quite as well in big multimodal AI workloads, or at least that's what we're seeing in our use cases.
Yeah, so I want to build on that for a second and ask the panel a question. So one of the things that we're finding is those heavy computation cycles are what we're using to find the algorithm.
Absolutely.
Right, so it's the data mining to try to find the pattern, but the actual application of the pattern in a lot of cases doesn't require a lot of computational power, right? It's finding that, in fact, a lot of our areas are 30, 40 different variables that you have to look at to make a decision. The application of those 30 or 40 is pretty small. So we're looking at edge computing by putting at each well site, for example, we're putting a certain computational ability to analyze data that's coming live, make real-time decisions. But it's taking all of that data to run these huge computational workflows to figure out what the actual real predictors are has been the challenge. Are you guys seeing that disconnect between the data scientists doing the computational workload versus the actual application?
I mean, unquestionably, right? I mean, there's the classic, train versus infer type of area when it comes to AI and machine learning, and absolutely the infrastructures are totally different, the workflows are totally different, even the teams that can take advantage of the insights are totally different. In some cases, even depending on your workload, even the data itself has to be cleansed and cleaned, and in many cases, that's a very human-intensive experience. So absolutely, I mean, you think about, these data centers that are getting built to, churn petabytes of information to learn interesting things. That's a, classic area where you need all that compute all in one place. Scaling it across GPUs is still very difficult, and a lot of hardware providers are working overtime to try to make more advancements and more chips to enable those kind of use cases. And then, like you said, you find that little nugget, then you pull that over, and you can totally do it on the edge. In fact, one of the reasons we're so excited about the work we do with Equinix is that we do see the edge as not just an opportunity for connectivity, but an opportunity to have the intelligence. If you can bake in the intelligence and create the learning right there at the transactional level, the moment a piece of information hits the network, then you can actually carry that all the way through instead of having the expense of always moving large amounts of information back and forth from node to node. So I totally agree with you.
Yeah, and we see the same thing. Like the building that, training the metric initially, obviously, it takes the load that you guys are talking about. The benefits come when you can take that and manipulate human behavior at scale, right? And you can cause 2,000 sales reps to change their behavior. And so I think being able to do both is key, and there are obviously different requirements computationally in terms of being able to achieve, like delivering 2,000 different answers to people concurrently has its own set of challenges versus building the training metric. But yeah, we do see the differences as well.
Good. Good. I'll take a question here from Slido. Maybe. Anyway, I'll just read it. It says, assume the data sets for AI are quite substantial. Can you provide some best practices in how to manage these large data sets? Which one do you backhaul? Which one do you keep local? And so I think that this is kind of going along some of this discussion tracks here. With the ability to aggregate all this information at the edge, how do you make decisions on it? And then what do you look for? Localized versus interactive type data.
Absolutely. I think it really depends on use cases. I mean, if you live in a multimodal world, which we do, right? Almost everything we do deals with the multiple modalities of information. Lots of different types of information all being streamed to the same central areas. You can think about it almost like data lake intelligence, right? Where you have lots of diverse things. So sometimes, and I think the hardest part, what this question is really getting to, the hardest part of something like this is actually sort of getting yourself ready for the fact that you actually don't know what information you're going to need in order to predict what you want to predict. And in some cases, you don't even necessarily know what you want to predict. You just know you want it to be cheaper, faster, safer, some cost function at the very end. So what we tend to do is we tend to design the infrastructure to pool as much diverse information as possible to a centralized core, and then understand when it finds something that it has a high enough confidence that predicts something else, right? And there's a lot of techniques upon which to do that, but when the system is looking through this massively unstructured information, the moment it gets to something where it says, oh, I think this is reliable, I'm getting this over and over and over again, I'm gonna take that, I'm gonna automatically pull this out and put it into production at the edge. Because the edge is processing the application information. It's processing the enterprise information in transit, almost like a bus, right? It doesn't have the benefit of you cleaning it properly, of you knowing exactly what you're looking for. So making that transition automatic and intelligent is, I think, what takes sort of an enterprise that could have petabytes of information but is bottlenecked in their learning by the 50 or 100 data scientists looking at it all the time and says all of a sudden now I'm going to create the computing power of 5,000 data scientists to do that job for me and then just automatically push it out. So it's almost like a different type of cloud orchestration.
Gotcha.
Yeah.
Gotcha. Yeah. No, go ahead.
I was going to build on that and say the one thing that we're starting to do is use more of what the industry calls a lambda architecture, where we're both streaming it and storing it both, right? So having something that's pulling data out of your stream to store it in that long-term data store. So what we're doing in areas like Northwest Texas or the Panhandle of Oklahoma, where you have extremely limited communication capability, is we're caching that data locally and streaming the events that you're detecting back over the network. So you're only streaming a very small subset of the data back, caching the data locally, and we're physically moving that to locations with Equinix centers and others up to the cloud, but then doing that big processing and then sending the small processing models back to the edge. One of the things I think you have to do, though, is, to your point, is think about you don't know what you don't know yet, and you don't even know what questions you're going to get yet, and you don't know what business problems you're going to have to solve yet. So the more you can do to capture, to your point, all of the data, so then when you do your data science work, you have it all. But differentiate what you need for processing versus what you need for storage and for data science work. Those are two different workloads.
Absolutely.
Hey, Mike, you have probably some of the most complex projects that are in process in the U.S. and around the world. How are you guys looking at some of the capture, gather, act on data from a CDM Smith standpoint?
I think I'd use construction probably as a primary example, but very similar to what you guys were talking about. If we have large streams of data, that we want to analyze as part of the construction process because we want to know what's happening in real time. So we might have ROVs driving, flying around, doing LiDAR, radar activity, monitoring things from visualization standpoint, and that data may be getting streamed somewhere and kept. But in real time, we just want to know what's changing, when it's changing, if there's weather patterns and things going on. We want to analyze that in real time. Now, at the end of the project, that's where the data scientists might say, hey, we want to improve our construction process, so what could we do with that data to help us determine what will make our next construction project more successful, better project on timeliness, and also better costs.
Got it. Anything you would give from an insight perspective of some of the bear traps or lessons learned that CDM Smith has seen as you've embarked on this, this cloud transformation and starting to look at some of the capabilities that AI and machine learning can help make your business more effective?
Yeah, I mean, I think number one would be diversification. I mean, having a centralized cloud, if you want to call it that, or a single data center, or trying to do everything and put all your eggs in one basket is probably the worst thing you can do. Giving yourself access to as many different cloud systems as you can, diversifying, and be able to access things the minute that something new comes around. And we've got new companies like Entefy and other people, MicroStrategy, that are coming online that provide new services. If you can't tap into those immediately, you're going to lose out.
Yeah. Absolutely. Got it. And maybe MicroStrategy or Hugh and Alston, kind of give me your thoughts on how latency, network capabilities, are affecting any of the AI services you guys offer. I mean, that was one of the questions I'm paraphrasing off of the pad here around, the effect these large workloads potentially have on, the network capabilities that are out there, and how do the workload sizing and moving, how are you guys taking that into account and trying to solve that?
Well, and to build on the previous points that you two gentlemen made, I mean, one approach that we've always taken is to make our architecture as open as possible, right? Because you don't know what questions you're going to ask next year. You don't know where you're going to want to deploy it. You don't know what system the underlying data is going to be in. So you need to be the Switzerland of BI or analytics or whatever to be successful in that environment. In terms of trying to navigate issues as they relate to the network, those technologies are often outside of our controls. The way we design our technology to enable our customers to be able to mitigate any of those risks is to try and push down as much of the algorithm, as much of the processing into the Hadoop data structure, into the database. And so we're always pulling as small amount of data back as possible, rather than push as much data as possible to the edge, which ties into some of the points we've already made. I mean, I think always trying to optimize and reduce the amount of information that comes back. For us, we're doing that because we want the response to come back faster. Right. We're not optimizing because I'm worried about the network guys. Maybe we should be. But for me, when someone asks a question, I want them to get an answer back in under a second, whether they're asking their iPad or Alexa or whatever. But I guess the network guys are happy that I'm doing that.
Well, I think building on that, I mean, we bucket latency into two big chunks, right? So there's the application latency, right? What are you willing to accept? You may want to, let's say, within a second, right? I think all of us, when we ask a question, we want an answer back pretty quickly. Then there's the actual infrastructural latency, which, yes, of course, no person should actually think about, but from a provider perspective, I think about that a lot, because when you're dealing at enterprise scale, it's never one person asking a question. And even when they're asking a question, it's rarely that they're ever one person asking a question to one thing very specifically. In the world of sort of the data lake and the high transactional environment that is the modern enterprise, every extra 10, 20 milliseconds can provide an unnecessarily massive load into your infrastructure. So it's not the fact that every use case needs to be solved in record time. It's the fact that if you don't pay attention to latency at an infrastructural level from a algorithmic perspective and a solutions perspective, you end up bottlenecking your entire infrastructure. So what you were totally okay with taking a second before, imagine their seconds are always serial, right? So all of a sudden the next guy may be 2 or 3. And not every use case is like this, obviously, and there are definitely some areas like high frequency trading which care far more about that latency than most everybody else. So we tend to bifurcate our architecture into allowing for both considerations. Don't burden the network when you don't need that real-time response, but at the same time, since many of the operations are inherently multimodal, to take advantage of the modern enterprise, that tends to mean that sometimes the same question is traversing text, it's traversing imagery, it's traversing videos. Like, that question is moving around, and I can tell you right now, like, a single video that needs to be brought in the network, whether it's streamed or saved or something, brought into the network, can suck up more compute than an entire, what a human would consider like wealth of textual information sitting somewhere on like a textbook on how to run this thing. So that difference means that infrastructure has to be smart enough to actually scale its algorithms totally independently. And that's a core set of some of the inventions we built pretty early on, actually, is how to actually have the infrastructure self-optimize to handle the load.
Got it. Anything you want to add on that, Stephen?
I would probably add the one thing that we've seen is that need to transition your organizational skill set to match that.
Yeah,
so as we start to think about our traditional data scientists even, who frankly, there's not a lot of them that have been traditional, right? But even people who come from school, a lot of their projects are one large set of data that was loaded overnight, go in and play with it and come out with an answer. The ability to do that in a stream is a totally different skill set. So for us, is transitioning from traditional BI, data warehouse style, nightly reloads and refreshes to streaming data and real-time analytics is a totally different skill set. So helping your organization identify and go through that transition process. I think the other one for us is the acknowledgement that data scientists who have all the computer science PhD and statistics PhD and a business like a geologist degree for us, right, PhD in one person is not going to happen. That's so figure out how you can get good teams of people who have the right interaction skills to transition that skill set. I think both of those have been two pretty good stumblings for us, is getting the organization to kind of come along to AI, is really getting people to go through that organizational change management process.
Well, the biggest hindrance to AI permeating the enterprise and AI solutions moving through the enterprise is talent, right? If you think about what it takes to grow a competent AI team that can compete with the others in your industry that have the same budgets, they can hire the same people to work on the same problems, there is not enough highly trained, specialized. This is not like normal software, right? And AI intelligence is an area where it really takes people who have specialized in very given fields, and then a nice sort of complex orchestration of those skills, because as you said, in every given use case, you're not going to find the 4 or 5 for one, or if you do, you're not going to find 100 of them.
Yeah, or you can't retain them.
Or you can't retain them,
frankly,
sure.
Right?
Yeah.
We've had them hired away from us by just about everybody. But
I'll try not to.
Appreciate that. But being able to start to bring together teams to focus on those problems together has been something that's been a successful way for us to mitigate that challenge.
And that actually, the point of like that you just made about AI permeating throughout the enterprise actually gets to one of the things in the title of this session, which I don't think we defined yet, which is like, what is an intelligent enterprise? Right? We're talking about all of the technologies, the AI or / machine learning, the cloud, the mobility. How do they fuel the intelligent enterprise? But that's it, right? An intelligent enterprise is one that uses information to execute on its strategies more effectively. That every single person in that organization is armed with information, whether it's been given to them because it's aggregated, or whether it's AI driven and it's automatically found its way to them, but they're doing their jobs better because of access to that data. And I think that's like, we're talking about all these different like moving pieces of the puzzle, but that's the ultimate goal, right? To make every enterprise an intelligent enterprise. And that pervasiveness of the results of machine learning, of AI, it really helps automate a lot of that.
Got it. Good. So we're talking a lot about data flows and how information's moving across the network and how it's being analyzed. GDPR, insights, views. Scared? I mean, how are you guys feeling about that? I know, Mike, you operate a large global organization that's always looking at data and all over the world. How's CDM Smith really looking at GDPR and how it's going to affect your business models?
Interestingly enough, for us, it's become a real compliance and legal issue. So our compliance and legal team has almost entirely taken it over at this point, in conjunction with our legal teams over in the EU. So they're really dictating to us what needs to be done, and what needs to be done on the technology side is actually far insignificant compared to what needs to be done within the rest of the organization.
Got it. Any other issues?
I think for us, luckily we're all North America, so not as much of it applies, thank goodness. But in kind of the preparation, that similar things would be adopted. I think the bigger challenge for us is historically we've operated within our walls. And one of the earlier sessions, we started talking about the competitive intelligence that you get when you start to work tighter with your partners. So we're starting to open up our AI platforms and some of our data lake to third-party partners. And that introduces that same set of GDPR concerns when we start to have third-party agencies who have direct access to some of our data. So one of the challenges we've tried to do is to try to get that data management function we've had historically in-house to start tackling a better data classification process. So data classification takes a long time, it's a lot of work, but the more you can get that progressed along, it sets the foundation to addressing a lot of the GDPR functions.
Got it. From a service offering perspective, are you guys building different based on GDPR hitting the beginning of the month and planning for how you're going to address that for your customers? Or are you guys just looking at it as more of an enterprise-based issue?
So I'm not sure about MicroStrategy, but we actually consider ourselves very lucky that a lot of how we built our original stack was kind of almost ready for this, actually, because we were looking at AI years ago, and you knew this kind of stuff was happening. You knew that people were going to start to highly regulate the sharing of information and the storage of information, the dissemination of information. There's just too much information flowing through these pipes for people to not care about how it's treated, right? So from my perspective, when we embarked on this strategy and we started to develop our AI platform, we call it the Mimi AI platform, we started to develop Mimi, we knew we had to do it from what was ultimately a person-centric micro-learning environment, which meant that you could even have this entire stack of intelligence learned from just a single person's behavior and information, for example, to serve personal assistance use cases. But you could also broaden her out. You could have her attach herself to just a specific machine in a fab. Maybe she takes on an entire fab. Maybe she goes across a metro. Maybe she's some combination therein, right? And that combination of small nodes and large nodes orchestrated across the network meant that the learning was always actually very well contained. You could totally control how much of those you allowed to work together. For example, let's imagine you're in Europe and I'm here. Well, we can, as people, we can totally control how much we actually share back and forth. It doesn't change the fact that while you're over there, you're totally autonomous doing your thing, I'm here doing my thing. If we treat the intelligences like these autonomous brains, so to speak, that are like people on a network, then you can actually have people here that don't talk to people over there. And when they do, they share very little amounts of information, or they learn by experience and stuff like that. So we were actually very lucky. We're pretty GDPR ready, like right off the bat. And I think that's actually, because it's been coming up in conversations recently, a lot of companies are beginning to get very concerned, like, oh my gosh, especially multinationals, how am I going to change my business processes? How am I going to change, my data storage and retention policies? How do, in HR cases, how do I even know, where certain assets are in my data lake? Because I don't have one, right? I have many, and maybe I don't even know entirely where they are and what data's sitting in. So that's where AI can really help, and AI like Entefy, to kind of traverse the network of the data lake and actually know exactly where everything is, so that you can then factor that into your business process and actually make sure you're in compliance.
Got it.
I don't know if you guys had a different experience.
No, there are multiple different facets of GDPR, right? Many are updating your terms and conditions. Some are like sending out an email to you saying, I would like to maintain a relationship with you. And we've all had about 74 of those in the last week. The lawyers are all on top of that. And there are some as it relates to, some as it relates to how you handle customers' information, right? So if you are an intelligent enterprise and you have a good handle of where your customer information is, who has access to it, then you're in a much better position than if you're running the business with Excel or some flavor of it and you don't know where the information is or who has access to it and there's no track. So more intelligent enterprises who have spent the time to apply some level of governance to customer data in the same way they apply governance to like salary data and the privacy around employees are going to be in a much better position than those who have been a little bit more, laissez-faire with it.
But I think it has to be a machine. It has to be a machine scale, though. I mean, I think that's the biggest change that GDPR has kind of forced into the enterprise, which is now you're dealing with so much diverse types of information. You can hire a team to do, salary, to make sure you're not mistreating employee or HR information, right? But you cannot have a team I shouldn't say cannot. It's too expensive and too costly for most organizations to have a team dedicated to knowing all the ins and outs of where all the information is sitting that could potentially relate to customers, all the information learned from your customers, all the information indirectly learned from your customers, and so on. And we saw the implications not directly related to GDPR, but in the same general landscape of privacy and security with Facebook and their recent stuff with Congress, and how everybody started to pull back. I mean, these are real implications that I think anybody who touches an end user, which is most businesses, are going to end up struggling with. And it has to be at machine scale because there's just too much information.
Got it. Question that came in is have you discovered any must-do in AI solutions to ensure security by design? Any thoughts from the enterprise side that you guys are looking at to must-dos from how you're looking at this to ensure security?
Yeah, so the first one I would say is that your data rarely lands in a place and stays there, right? Your data almost always goes to somebody copying it to their notebook or project or to another database, another system. So don't think about security as an aspect you apply on a system. It's always something, even your data lake, you always have to think about all of the many copies that are going to be made of that data set. So we take it from more of a data classification, classify your data, make sure there's a systematic way to represent that classification in your model, and then apply it no matter where it's at. So whichever copy it's made into, your governance really needs to be around what's the classification of that data and the security for that class, and then you're applying it consistently across the enterprise and not really tightly controlled here, but then a copy over here, everybody in the company has access to it, right?
Got it.
Yeah, it's 100% spot on, exactly the way we're addressing it as well.
There's on top of all that, because that best practice solves like a huge chunk of that challenge for sure. And companies that don't go through that little step, they're just setting themselves up for failure in that regard, I think. One of the things we did on top of that was to create a deeper integrity in the actual data pipeline itself. We invented a couple of unique pieces of technology. We call it adaptive privacy controls. And really what it is, it allows an organization to take a variety of different types of information, structured, unstructured, textual, visual, or otherwise, and apply, we'll call it pixel level encryption, sort of the ability to take a single bit even and actually encrypt it at that level. So you can have, let's say, a knowledge management system with a lot of documents about very sensitive customer information floating all around your enterprise, stored in 50 systems, transacting across 20 networks and 30 partners. But as long as you applied APC at the very, very first layer, you can be totally ensured that even a small subset of information within even the same file, so a particular social security number in a particular spreadsheet, has a particular invisibility to any node except for the one authorized channel, which means that from an algorithmic perspective for machine learning, you can even have an AI system that's not provisioned to see that information at all, still operate on the exact same data in the exact same storage environment that's storing everything else, which means you don't have to replicate as much. You don't have to track different versions. You don't have to put all that complicated logistics inside your infrastructure. So it actually brings the cost way down in terms of data governance. So I did want to throw that in there as well.
Got it. Good. Good. Any lessons learned anybody wants to share? I know you guys are pretty advanced in both your design, deployment, and execution of some of these AI cloud strategies. Anything you want to share with the audience that you wish somebody would have told you as you guys are embarking on this?
I think the first one is that I would start small. A couple of our projects we had were really large and really ambitious, and start task-based. And apply it for a particular task and then chain them a bunch of tasks together. I think ours were early on were too large in nature, and even at a process level can be too big initially. So if you go in and say, for example, I want to automate the classification of invoices when they come in. That can be an entire process, right? So think more about applying, especially machine learning, at determining the classification of an invoice as a step in the process and trying to figure out how to automate that function end to end and get something deployed in production and build over time. More of an agile approach. I wish we would have taken it a little bit different. And then the second one I would add is the data quality and data enrichment should be something that you should build into the upfront on every project. And what I mean by data, I think everybody knows data quality, right? There are multiple variants to that, but The data enrichment is one where a lot of data we get, for example, that comes in from a particular piece of equipment, we'll have the equipment ID and then the values, right? But there's stuff that we can, by using that equipment, we know what field location it's in, who the operator is, what the operator's superintendent's name was. If you can enrich that data, then it becomes much, much more useful in a lot of your downstream systems if you capture that while it's happening.
Got it.
I would say, I mean, if the goal is building an intelligent enterprise, yeah, the data quality, you could put AI on crap data, you're going to get crap AI, right? So being able to have good quality data that you can trust, I think is critical. The one other piece I would emphasize that we haven't touched on or isn't touched on in the title is the end user experience, right? If you want to build an intelligent enterprise, the focus required of making sure the interface the person uses is, like, you could ruin all of the investment we've spoken about if the user's not going to touch it because it's ugly or it's awkward or it's hard to learn. Like, that you need to surface all of this value in beautiful, incredibly easy to use, enjoyable to use applications, assuming that, you know, humans still need to touch these things and it's not all automated work, which I think is still going to be true. But I would say don't underestimate the importance of taking this value and surfacing it to people in interfaces where you've spent just as much time and concern and energy as you have in the plumbing.
Got it. Good, good.
If I can,
Sure, go ahead.
Sorry, there's one other one that was one that I feel like is a pretty important lesson learned for us, and that is anytime you take more of the intelligent automation or intelligent tasks that are intended to reduce your human labor workforce, I'll put it that way, one of the things that's really interesting is a lot of people say, well, our humans today are doing a really bad, crappy process, right? So we want to go in, and in addition to automating that activity, we actually want to clean up the process. One of the things that we found has really helped our success is automate the crappy process, take the people out, and then go back and change the process. Because if the people aren't there, there's not as much resistance, right? So it's just kind of a learning that we've found is that taking that process, automating it, and then going in and start tuning it is a lot easier to do than trying to tune it with all the people and their desires to make the process work a particular way.
If you don't mind, Ryan, before we move on to this is an important area, so I did want to add, following what you were just saying, I think the biggest one, because we learned this ourselves, and I think it's true for anybody trying to embark in this area, is the intelligent enterprise is too big of a transformation to actually do alone and to do entirely internal, I think. It's one of those things where, I mean, just by example, it takes too much time, so you have to partner. So for us, you know, our team, this is our entire business, and it took us 4 years to build an underlying multimodal platform that could extend across our company's sets of use cases, because you also don't want to digitally transform or intelligently transform in just a narrow set of slivers. The whole idea is to take advantage of the scale in the enterprise, is to do it across the stack, both horizontally and vertically. So that transition, most teams in the world are not well equipped to actually do that. It's a set of expertise, to what you were saying earlier, that not everybody has, and it's also, frankly, a set of priorities that the organization doesn't necessarily have. If you are not an AI service or product company, that's not your core business. Therefore, there's naturally going to be more resistance. There's naturally, whether it's intentional or not, you're not going to have the same kind of support ecosystem. But if you partner up with a company that's sole job is to do that, and has already spent the multiple years on that, you can jumpstart that process, saving in some organizations, you know, hundreds of millions of dollars and at least a few years worth of development by just skipping over all those big mistakes that we've already gone through.
Got it. Good. We'll jump in here to a question that came in. It's you know, tying into Hugh's comment about user experience and enterprise around knowing your customer is one of the keys to success. Provide some specific examples around how AI and machine learning helps actionable knowledge for customers. So, you know, I guess, you know, how can, you know, some of the services, you know, that are driving AI and machine learning provide end results for customers?
So I'll tackle one for us. So one of ours is for our business partners, a specific example, right? Is that one of our strategic partners is trying to figure out how to, when we drill in an area, they operate that area for us. We're providing more targeted information directly to the individual operator, directly to the specific well. And what that gives us is the ability to do is instead of them going and visiting every well and our service costs going up every day, run the same route every day, is we're asking them now to start to visit specific ones on a managed by exception basis, right? So they may not visit that particular one for 2 or 3 weeks, and that's okay because they're visiting the ones that really need to be visited instead of just running the same routes, right? So by giving them targeted information about exactly where we need them to go work, we're getting a lot more effective turnaround in the way that our partners are interacting with us.
Got it.
I think banking has quite a few use cases for this. KYC is a whole area there, right? Know your customer. And so when it comes to the inefficiency organizationally, that ends up creating with a lot of human effort to to know your customer, to offer better services, better solutions, optimize portfolios. And this goes all the way from the retail stack all the way up to the very top end of institutional portfolio management. So I think it extends across, but I would say banking and finance is one of those areas where we're seeing KYC really, really have a direct play from loan approvals and modifications to product offerings and things like that.
Yeah, and the algorithm we see applied the most in terms of customers. Once you've got that set of customers, whether it be like the omni-channel vision of the customer or whatever it may be, it's customer churn. Right? It's somewhat of a classic, but when you can apply better and better algorithms to predict when you're going to lose a customer, and then you can build algorithms to also not predict, but suggest what you should do to retain that customer and even automate those offers going out, then you've got a system that's checking for churn and responding to it without someone having to be involved. And I think those are cross-industry, right? They apply to banking, they apply heavily to retail, but we're seeing that one used extensively.
Yeah, so I'd like to jump in here too. I think smart water analytics is something that we're looking at, and one of the big things we're seeing right now is understanding when there are significant rain events or disasters that are coming in, and understanding what the water flow is going to be like throughout a city or an entire county, or in some cases multiple counties, and being able to predict accurately in real time where overflows are going to occur or where they need to redirect water so that there's not flooding at a really major part of a city. Which can save lives, to be honest, and also something that's actionable by the individual cities and municipalities, and they can actually take action on things much faster than they could before. In fact, most of it can be completely automated, so they don't even have to do most of the work.
Got it. Yeah. So this may be a semi-loaded question. It came in from the audience. They wanted to know, where's the best source to find data scientists?
Not at Devon.
Not at Devon, huh? Yeah.
My team, but you can't get them.
Yeah. Yeah. I think
are we supposed to say MIT?
There you go.
Right.
There you go. So semi-loaded. I didn't know if anybody wanted to share kind of through their overall focus. That is an area. It doesn't matter if it's in our industry in the data centers, or you all have diverse vertical focused. Where are you guys finding talent?
Yeah, I think for us, it's a lot of the technical professionals in other areas of the company. So we're finding that we can teach, the good business logic and statistics to some of our computer scientists is really hard. So we're actually finding better luck, as I mentioned, bringing teams together, having a computer science paired up with somebody with good business acumen. But we can take an engineer, a geologist, or other technical discipline practitioner who's already in the company and teach them the basic computer science and not usually the statistics. They already have to know statistics, right? But if we can take that group of people and train them up, it's a lot easier than trying to go, in a lot of cases, hire people away. So if we can hire in a geologist even from another company and train them because they know the business discipline side of it and the technical side, we're finding that conversion from that technical resource pool like engineers to be pretty good.
Makes sense. You guys are.
I'm keeping my pool private.
Yeah.
I'm not going to tell everybody where to find great data scientists. That's my job.
Got it. Good. Well, we're wrapping up here in a couple minutes. Any last thoughts you want to share with the audience? I think that, I know walking around and talking with people, this is a topic that's and on forefront of most people's minds, and they're really looking at, what do we need to plan and what do we need to model? Anything you guys want to share, in the last couple minutes here before we wrap up?
I'll just say the one big thing, and then I know everybody's got something to share here, but the biggest thing for us, the part it was a guiding force of kind of why we got into this sort of landscape to begin with, and why we think that the approaches really matter, is this focus on ensembled multimodality, right? So the fact that very little of the intelligent enterprise is going to be focused on singular streams of very specific or clean data is what makes this problem hard, right? If everything was clean, if everything was the same, you wouldn't have this problem, right? Data science and statistics and core software has been able to deal with data, even sometimes with teams that deal with ETL, right? I mean, these are things that have been done in the enterprise for quite some time. What makes it difficult and what makes it necessary that we have an AI transformation in the enterprise is this fact that we are now extending beyond just the realm of singular streams of very clean and well-structured information. We are moving into a world where the real gold mine for a given organization is in the unstructured data. It's in the data of how their teams communicate and share information. It's in the knowledge embodied in the sales process when you talk to the customer. It's in the knowledge that is present at the machine level, but can never really be pulled out into the human level because it's about the machine, right? Not about the human process. And so unifying that stack from the lowest levels of the fabric of the internet, right, the interconnection all the way up to the end user experience, and creating sort of a single intelligence membrane that can move across that layer. I don't mean to say a single intelligence that knows everything all the time. We're still quite some time away from that. But we're talking about a same infrastructure and the same pipeline that can support all those different use cases and ensemble itself and orchestrate itself to meet the end. That multimodality, I think, is core to the strategy. So any AI strategy not based in multimodal intelligence, I think, is a little bit like the very first early waves of the cloud. It's like, I'll put my CRM data in the cloud. And that's a very small part of the digital transformation, the cloud transformation. So I can't stress enough how important that multimodal focus is. And that does make things a lot harder, but it also makes the opportunity for value so much greater.
I would just say that a lot of this stuff is, if you're an organization that is still running the business using Excel, a lot of this stuff is a number of different stages away. I think the process of building to become an intelligent enterprise, or if an enterprise isn't your scale, an intelligent organization, is a multi-stage process, right? It requires that you go from analysts having access to information and pretty much keeping it in silos all the way through to every single person in the organization has access to information they can trust, that's not only helping them make decisions, but recommending they make decisions or making decisions on their behalf. Like, there's a number of different stages in between that. So don't get overwhelmed with the fact that you can make significant progress incrementally, taking advantage of a number of the different things that have been mentioned, from the availability of cloud. Like, you're not failing if, as of tomorrow, you didn't move all of your on-premises stuff immediately to the cloud. Some organizations are incredibly well-run intelligent enterprises with a number of different things in the cloud that have dedicated VPNs back to information that's on-premises, and and interesting hybrid models. Like that's perfectly fine. So I would just be conscious that there's an incremental set of stages to becoming an intelligent organization, an intelligent enterprise, and to work through that.
Yep. I would probably jump in and say that you stole one of my ones earlier, which is focus on the business problem, right? Make sure to be an intelligent enterprise, you have to apply it to a business problem and solution, and make sure that you define those outcomes for the team and not try to solve the problem for them, let them work that problem. But I think the one lesson learned, and kind of another lesson learned that we had as a big takeaway was, if you really think about the biases that subject matter experts bring to the table, because we have training and discipline, there's a lot of the machine learning where they come up with things that we've never envisioned before, right? So really let the technology do its work, and sometimes you'll find interesting insights that you hadn't seen before. So that's maybe another takeaway.
Yeah, I think building on what you just said, also take into consideration the people aspect of this, which is a lot of people are afraid that they're going to be put out of their jobs or that something's going to be automated that's going to actually do a better job than they are. But if you look forward and change the perception, you can get them to buy in and become advocates and actually speed the process up at the same time.
Thanks, guys. Well, I mean, everyone, these are 4 experts that have embarked on this in this journey, either from the demand side, meaning their enterprises looking at this, living it, and adopting it in Stephen and Mike, and also we've got a couple platform providers here that have deployments in place and they're operating this, and so they're addressing challenges for a lot of customers. So if you have questions that we didn't get to, or there's some ideas that you want to bounce off them, they're going to be around after the session. So I would say, grab them. They know a lot more than we were able to get to here today, and their insights and experiences can really help you start to understand either where you need to go from a plan, or how to implement the plan, or just some of the things that you may want to consider, because they've all lived it already. So with that, I'd like to just give these guys a big round of applause, because I think that the experience